Welcome back and welcome to your last set of volume notes. We're going to be doing the volume of spheres today. Oh, nice. A sphere is defined as the set of all points in space that are equidistant from a given point, which we refer to as the center of the sphere. Well, that was kind of cool. I just typed right on there, but I don't think it worked. Oh! Sphere. Set of all points in space equidistant from a given point. That given point is called the center. The diameter of a sphere is similar to the diameter of a circle. It's going to go all the way across, and it must pass through the center of the sphere. A radius is going to be half the diameter, so it's going to go from the center out to the edge. I'm going to write center to edge across through, holy cow, through center. Alright, so radius is half the diameter. Remember, volume is the number of cubes that fit on the inside. So we're still trying to figure out how many cubes will fit into a sphere today. To find the volume of a sphere, the formula is 4/3 pi radius cubed. So the only thing you need to know to find the volume of a sphere is the sphere's radius. And then you're going to throw it into the formula. So for example 1 here, it says find the volume of these two spheres. Well, when I look at 1a, radius, remember, goes from the center to the edge, would be this segment here, which is 9 centimeters. So we're going to throw 9 into the volume formula. 4/3 pi 9 cubed. When I leave this in exact terms, I'm going to take 9 and cube it, which just means multiply it by itself. And that's going to give me 729. What I like to do from there is take 729 times the numerator of 4 and then divide that by 3 when I take it times 4/3. So this would be 972 pi centimeters cubed. Now if I asked you to round it, then you'd have to put it in your calculator, 972 pi, and that would get you about 3,054 centimeters cubed. Make sure you know how to use your calculator, whether you have a fraction button or what, but you need to know how to use your calculator. For B, we have this segment here that's 14 inches. Since the whole segment's drawn in, then that's referring to the diameter of it. But in order to find volume, we need to know the radius. So I only want half of that length, which would be 7. So then the volume of a sphere, 4/3 pi 7 cubed. Okay, in exact terms, we're going to take 7 times 7 times 7. We're going to cube that, and we get 343. I'm going to take that number times 4 and then divide it by 3. It does not come out even. So what I would do is just do the 4 times the 343, which is 1372. So I would write this as 1372 pi thirds inches cubed. If you want to write it as a mixed number, fine. I like improper fractions. They feel like they're kind of easy. If I wanted the approximated value of this, 1372 pi divided by 3, which is about 1,437 inches cubed. Good stuff. Last one here. Number 2 there on the bottom says the volume of a sphere is 288 pi cubic centimeters. Find the diameter of the hemisphere. Well, the diameter of the hemisphere is going to be the same as the diameter of the whole sphere. A hemisphere is just being cut in half. They're giving us the volume here, so we're going to have to work this thing backwards. Volume of a sphere, 4/3 pi radius cubed. Okay, if I know that the volume is 288 pi, then I'm going to put that 288 pi in for the v. So it's going to look like this. I don't have much room here, so bear with me in my handwriting. 288 pi equals 4/3 pi radius cubed. Okay, now remember, the diameter is the same as 2 radii. So I first have to figure out what r, the radius, is, and then I can find the diameter. So I need to work this equation and solve it for r. What I like to do is get rid of pi first. Since pi is being multiplied on both sides, when I divide by pi, it simplifies to 0. So now I have 288 equals 4/3 r cubed. Now dividing by fractions, yuck, we're going to multiply by the reciprocal on both sides. When we multiply 4/3 times 3/4, we'd get 12/12, which is just 1. So then on the right side, we're left with r cubed. Now on the left side, we have to take 3/4 times 288, and that gives us 216. Okay, we're getting really close because now we've got r cubed. So I need to get rid of the cubed. You know when you do the Pythagorean theorem and you get down to something being like x squared equals 144, to get rid of the square, you square root both sides, right? The inverse of squaring is square rooting. Well, the inverse of cubing is called cube rooting. And what you do is you just put this little 3 inside of that radical symbol. So what we're going to do is take the cubed root of both sides. Good luck finding this on your calculator. Maybe the internet has it where you can just type cubed root of and throw it in there. But the cubed root of 216, you guys, is 6. Meaning 6 times 6 times 6 would get you 216. So there, we know that the radius is 6, but we want to find the diameter. So to find the diameter, we're going to take 6 times 2, which is 12, and we have a diameter of 12 centimeters. Oh, I have a couple on the back. Cool. Perfect. I'm glad I'm not done yet. Find the volume of the figure number 3. We have a composite figure here. It's made up of more than one. On the top, we have a hemisphere. I mean, you could say half of a sphere, but I'm just going to call it a hemisphere as that's what it's referred to, or that's what it's called. And then on the bottom, we have a cylinder. So we're going to find the volume of those two and add them together. To find the volume of a sphere, it's 4/3 pi radius cubed. Well, if a hemisphere is half of that, then we're going to take that value times a half, or divide it by 2. Cylinder, this is from the other day, kind of like a prism, big B times H. I'll just start on the left here and go with the hemisphere. In order to find the volume, I need to know the radius, which they tell me is 8. So if I plug that in, 1/2 times 4/3 pi 8 cubed. We're going to leave this in exact form, you guys, so I like to work it backwards. I would take 8 and cube it, which is 512. Take that times 4, divide that number by 3, and then divide that number by 2, because it's a hemisphere. But it's not coming out quite evenly. What it is 341 and 1/3 pi. So you could write it like that. Or if we were to leave it as an improper fraction, 1024 pi over 3. This answer and this answer are the same. One's a mixed number, one's an improper fraction. That's only representing the hemisphere. Now I need to go through and find the volume of the cylinder, which is big B times H. Remember, big B, area of the base. Well, on a cylinder, the shape of the base is a circle. So to find the area of a circle, it's pi radius squared. The radius is the same as the radius of the hemisphere, so pi times 8 squared gives me 64 pi. The height of a cylinder must connect the two bases, so the height is going to be 18. So to find the volume here, we're going to take 64 pi times 18. 64 times 18 is 1152 pi. Now what we need to do is add these two volumes together. Well, if you take 1152 plus 341, that's 1493 and 1/3 pi millimeters cubed. If you wanted to write that as an improper fraction, 4480 pi over 3 millimeters cubed. If you wanted to take that and round it to the nearest whole number, should get about 4,691. Awesome. Cool, cool, cool. I'm just seeing if I write it this other way, if it works also. Sorry. You could work on number 4 if you wanted to while I take my time to type this in here. Yeah, it worked. All right. Awesome. Last one. A cone is surrounded by a sphere. Find the volume of the space between the cone and the sphere. We're going to need to subtract this time, you guys. So we have this cone inside of a sphere, and I want the volume of the space between here, here, and all under here. All right. So whenever we have these subtraction problems, I always like to explain it that you need to find the volume of the outside figure, and then you subtract the volume of the inside figure. So our outside figure is the sphere. To find the volume of a sphere, it's 4/3 pi radius cubed. The radius must go halfway across the sphere. Since that whole line is drawn in and is labeled 20, that's representing the diameter. Therefore, the radius is going to be 10. So 4/3 pi times 10 cubed. 10 cubed is 1,000. 1,000 times 4 is 4,000, which is not divisible by 3, so I'm just going to write that as 4,000 pi over 3. That would be the outside, that's the whole sphere. Now we have to find the volume of the inside, which is a cone, and to find the volume of a cone, it's 1/3 big B times h. Big B stands for the area of the base. On a cone, the shape of the base is a circle, so pi radius squared. The radius is 10, so that gives me 100 pi. The height of the cone must start at the vertex and then go down to the center. It'd be this red segment I just drew in. The height goes from the center of the sphere out to the edge of the sphere, so it's actually a radius. So the height will also be 10 here. So when I go to find the volume, we're going to take 1/3 times the area of the base, 100 pi, times 10, and that gives me 1,000 pi thirds. I want the volume between, so we need to subtract 4,000 pi thirds minus 1,000 pi thirds, subtracting this and this. 4,000 minus 1,000 is 3,000 pi thirds, and this is going to be simplified, so it would be 1,000 pi meters cubed, which is roughly 3142 meters cubed if we were to round that. All right, I hope you enjoyed spheres. Have a great day.